So we're going to see whether the car in speed could actually make the jump, right? So as you saw in the video, there is no ramp, all right? There may be a ramp way before the bus leaves, but there is no ramp before and when it actually leaves. So it's leaving with a horizontal velocity, okay? And then it's going to take a parabolic path down. And the question is, how much is it going to drop? If it only drops a little bit, right, you could imagine that the wheels could handle it, right? You can you could drive over a 1 foot curb and it wouldn't stop the bus, right? But if it drops a lot, it's not going to make it. So we're going to find out how much it drops. So as it talked about in the instructional video, we're going to separate this into X and Y, because in the X, we have constant velocity, and in Y, it's accelerated motion, all right? So we're going to separate those into vectors, right? Components, okay? And so what's actually happening any moment here is the bus would be kind of going diagonally here. But then we could separate that velocity into an X component that never changes, and a Y component that gets longer and longer as it goes. But the actual velocity is kind of a diagonal velocity. That's a combination of both of these. Okay, so what do we know? We know the velocity of the bus. So right before it takes off, it's going at about 68 miles per hour. And I have told you before that a mile per hour is roughly half of a meter per second. It's exactly 0.447 meters per second. So I'm going to go ahead and do that conversion now. Okay. And the bus is going at about 30 meters per second. Okay. That velocity never changes. All right. And then we have the velocity, the Y motion. Now, it might seem, again, like we don't have any information at all here, but we do know that everything near the Earth is accelerating at negative 9.81. I'm going to say that right is my positive direction and that down is my negative direction. This is a little different than how they did it in the one video. But I like to use down as negative consistently unless I have a really good reason not to. All right. And we want to know what the height drops. That's our unknown. And I'm going to call that dy. But now over here, we already have enough information to use a formula. But over here, remember, we got to get at least 3 things plus the unknown. And where's the rest of the information coming from, right? So there's one other piece of hidden information that we do know, and that is the velocity in the Y direction when it first leaves is 0. Okay, this is hidden information. And basically, any time you see words like horizontal, fired horizontally, or if it's leaving at the top of a building and it's going down like this, you can infer from that VIY is equal to 0. All right, that when it first leaves, it's not got any velocity in the 0 direction. But we still need one more variable. And when in doubt, you should always find time first, because time is the thing that unites the X and the Y. All right, there's no such thing as X time or Y time. It's all the same time. Okay. Once we realize that, then we can pick formulas. So for this formula over here, we're always going to use V equals D over T, because this is constant velocity. And when velocity is constant, it means we can use the average velocity formula. Over here, we have to pick our formula from our reference tables. And I am going to pick the formula D equals VIT plus 1/2 AT squared. Okay? And you can either be really careful about keeping your X separate from your Y, or you can put little Y's here. I don't usually bother to put a Y next to the acceleration, but realize that that is that acceleration. When did I lose my freaking camera? Hopefully not a long time ago. Sorry. There, that's more better. Okay. So I don't usually bother to put a Y here, but you should realize that there is no acceleration in the X direction. That is 0, which is why we're using this formula. And the Y is where the acceleration is happening. All right. Now, this whole term drops out because there is no initial velocity in the Y direction. So I can go ahead and solve this. I'm going to solve one side for time, and then I'm going to solve this to find our other answer, right? So start here. We can solve this for time. I'm just going to plug and chug. All right. I still got the camera. I'll move it up slightly. Okay. All right. So let's see. Let's plug in 30 meters per second equals. There's one other thing we need to know is how far did it go, right? In the horizontal direction. And we know that too, all right? The dx is actually 50 feet. And if I go ahead and convert that. Okay, so to convert from feet to meters, 1 foot is 0.3048 meters, so 50 feet is about 15 meters. So I'm going to go ahead and put that in. 15 meters all over seconds. All right, pretend both of these guys are, this is over 1. I'm going to just cross multiply and drop units. So I get 15, it's 15 meters over, and I put in S here, but I should have written over T. That's silly. All right, so 15 times 1 equals 30T. So T equals 0.5 seconds, and that's true for both sides. So I can now take that in and plug it in over here. So I get dy equals 1/2 times negative 9.81 times 0.5 seconds. Okay, and if I do the math there, I get that dy equals, let's try that again, 0.5 seconds. Oh, don't forget to square it. There was key. Common mistakes. All right. And then I'm going to multiply that by 0.5 and 9.81. And I get that the distance it drops is negative 1.2 meters. If I want to know how many feet that is, if I convert to feet, I can then just take that and divide it by 0.3048. And I get that that's equal to about 4 feet. So we're going to give our answers in 1.2, negative 1.2 meters, but it's actually falling about 4 feet, which means that basically Sandra Bullock is going to take this highway right to the face.